Hi, everyone. Thank you, Sakshi. My name's Thomas Addison. I'm an applications engineer for OptoTest. And today I'm here to talk to you about the technology behind our production style software suite, OPL-CLX. So first, I'd like to start with a little bit of overview about OptoTest and what we do. So we design fiber optic test equipment. We've been doing it for close to 20 years now. We tailor our test equipment and software to the needs of our customers. And all of our products are designed and manufactured in the USA. So first, I'd like to start with kind of an overview of OPL-CLX and what it is and what it does. So we've kind of have our main application, which is OPL-CLX. This is where you spend most of your time in a production style setting, testing insertion loss, return loss, things of that nature. We've also got our 6 support applications, is what we like to call them. So these are kind of the building blocks that put together a session that you can use to actually test, cables and things like this. So a little bit more on those. There we go. So this is kind of a test process that we would follow for the software. Oops. My computer doesn't want to get along with me today. Apologize. So our test process, so there's really 2 avenues in order to get to kind of a setting where you can test in the software. So these are our building blocks or builders, as we call them, to create a session so you can spend time in OPL-CLX main testing things. So the more complex route for more complex assemblies are the builders. So this is here on the left, the DUT builder. Of course, you build the device that you'd like to test in this application. The instrument set builder, what instruments do you want to use to test this? The sequence builder, which order, which steps would you like to take? Would you like to measure insertion loss, return loss, just insertion loss, etc.? The configuration builder, so these are more personal, how many significant figures would you like to show, or how many times would you like to retest, kind of personal settings, company to company. And then the test package builder kind of wraps this all up together to create a test package that you can use to create a session to test. We have recently introduced a more streamlined version of our 5 builders, kind of 5-in-1, what we call the session synthesizer. So the session synthesizer gives up a little bit of the control and flexibility you would have using the 5 builders. However, it is easier to use and a quicker way to get testing. So we'll go into kind of which path you should take for which application in a minute here. But either avenue you take gets you to what we like to call a session. So I'll cover sessions more in depth, but basically a session is a space in which all of your testing, referencing, things of that nature take place. So once you're in the main software here, your operator or user would select a session. They would enter their pertinent order information. At this point, they reference with their physical reference cable setup. You connect your DUTs, you perform tests and measurements, and then the software will export data. So how do you know if you should use the session synthesizer or the builders? So what we've kind of deemed as simple assemblies, these are, your simplex setups, duplex non-hybrid setups, MPO connectors, non-hybrid. These are a simple assembly. So these are more of a top-down design philosophy. And again, we recommend using the session synthesizer for these. These are more straightforward. But again, you have less control and less options for the test setup, but it is quicker. For more complex assemblies, so we would define these as something like bundles, ruggedized assemblies, Fano cables, multi-channel hybrid cables. This is a bottom-up design, so you would go through all of the 5 builders. This offers you greater control and greater options and greater configurations. However, it does take a bit more time to set up. Once we're set up and you've created a test package and a session, you're ready to start testing. So I'd like to go over kind of what's in a session and why we've chosen to use sessions in this software. So a session is basically compiling all parameters of a test into one kind of discrete location. So you can see here session 1 on the right, the top right. This is kind of the information is what we call a full session. So you've got your test package. So the sequence, the DUT, the instrument that you set up. It also has your plugin parameters. So plugin parameters are things like test reporting. How do you want to do that? Instrument plugins. So how does the software interface with hardware? Things of this nature. It also includes your reference data. So it will save the data. The software uses the data here. So your insertion loss references, your return loss references. It's also got your batch data. So batch data is serial numbers, production style testing. serial numbers, order information, purchase orders, job numbers, work orders, etc. And of course, it also holds the test data. So you can reference each serial number you've tested and see the results and kind of criteria it was tested against. So that's a session here on the top right. This is a full session. The bottom right is an empty session. So why did we choose sessions? Well, sessions give a local backup. So this is kind of a directory stored. You can go back and access these sessions anytime you'd like. All of your test data is stored within them, your reference data, batch data, etc. Again, sessions organize this data, so it's very easy and accessible. They're portable, so if you've got an entire production line and one person would like a backup of all the sessions to look and analyze this data, you can move all of your session files to one location and access them from anywhere. And they are self-contained. So assuming you don't make any changes to session one will exist there as a file for as long as you need it, and you can access that whenever you'd like. Another nice feature and kind of a testing process we recommend is session templates. So a template is an empty session here at the bottom. This is basically just your test package and your plugin parameters. It has no reference data, no serial numbers, no test data yet. These are kind of used as a way to create sessions quickly. So if you have a high volume DUT you like to test, you'd create a session for a specific work order, test it, run through it. And then, 2 weeks from now, you get another order for this high volume DUT. You'd go back to your session template, open up another template, and then you'd have a brand new session to start testing again. So it's a good way to stay organized and kind of track data. And again, just to kind of go over one more time, the session is basically a compilation of either the session synthesizer or the DUT builder, or excuse me, the CLX builders, which includes the DUT builder, the instrument set builder, and the sequence builder, kind of all put together. So now that we kind of understand what a CLX test is and kind of how we use this for measurement, let's talk about plugins and how we're going to expand the software to kind of meet user and customer needs. So we'll be doing this through plugins. So our plugin structure allows for large CLX updates without core system changes. So what I mean by this is we'll be able to, a customer can request a feature or something, or we make a change in the software. We can send someone a plugin. They're installed through the OPL-CLX main application, so you don't need an entire software update to receive a new feature or expand on that. So the software is going to utilize our plugins to handle for future feature requests and things of this nature. So we've kind of broken down plugins into 3 categories for now. Our first are instrument plugins. So these are how the software interfaces with hardware. So, and we've kind of structured the instrument plugins with expansion in mind. So at the moment, the software can interface with these kind of 5 categories of instruments. We'll be able to expand to even cover non-OptoTest units at some point. But for now, what it kind of looks as is it doesn't look at an OP750, which is a multi-channel light source. It just categorizes this as this is a source. So the OP750, the OP250, these are light sources, but the software doesn't look at it as an OP750. It looks at an OP750, categorizes as this is a source instrument. So this kind of allows us to create new source instruments without having to really kind of redesign the software. The same goes for our optical power meters. So our OP710 or OP735, things of this nature aren't referred to as this is an OP735, this is a 4-channel power meter, rather as, oh, this is an optical power meter. I can assign this to take a power meter measurement. The same goes for an insertion loss setup. So our OP815 is a source and an optical power meter. So the software sees an OP815 and realizes, okay, this is a source. This is also an optical power meter. So I can assign this to do both of these things. The same follows for an insertion loss, return loss measurement. So our OP940 can do both of these things in one unit. So, or our OP925. So the software sees this and it goes, okay, this instrument can do source, it can do optical power meter, and it can also do a return loss measurement. So it can kind of fill in the requests made from the sequence. So it can kind of interface with many different units at once without having to kind of reconfigure things. And of course, it also works with our optical switches. So our OP720 or our OP725. Again, it doesn't look for specific units, it looks for function rather than part number, and it can assign many different part numbers to do a function, assuming they can do that based on the plugins. And again, this allows us, if we were to release a new unit or a customer has a request for an instrument, we can create a plugin to fall within these parameters. Next, we've got our output plugins. So this is kind of something new with OPL-CLX. So basically, our session, when we're testing, will output test data. At that point, that's the last step of what the session does, and it exports the test data to our output plugins. So right now, we kind of categorize the output plugins into two different locations. I'll start with the right, which is our basic test reporting. So these are things like a label report. We give the software a template. It can output the data into an Excel template and automatically create a label, print the label for you on a successful test. It can also do things like a specialized Excel template report. So you customize the template, we configure the software, it exports that data to that template. So you can save it as a PDF, a CSV, XLS, etc. And another new feature we've recently added is called the summary test report. So let's say you test 100 cables in your session. You can generate a summary test report. Well, we'll basically print the results from those 100 cables on one document, if you're interested in something like that. On the other side, what we'd like to call more advanced test reporting, OPL-CLX can interface with an SQL server. So we can now export to a database. So the database is useful for, of course, storage. You can have multiple production style settings, all exporting their data to one location. This is useful for things like interfacing with something like Metabase for data analysis, or it allows for more advanced and kind of configurable test reporting. So things like setting up macros or data analysis on larger scales, test reporting. And kind of the last big output feature right now, or big plugin branch, are UI plugins. So our user interface plugins, these are features that don't use the OPL-CLX engine. So what I mean by this is we define the CLX engine as the builders, test reporting, and referencing. So these don't do any measurement, and they don't do any test reporting. They don't export any data. They're more, of course, based on the name, user interface. So these are things like our OP415 polarity checker. So this is kind of the first user interface plugin we made. This will interface with our OP415, which is a polarity checker. And basically what it does is it kind of creates a new box in the software that allows you to check for polarity before testing. So you can interface with this, check polarity, and then continue testing. Ways we can kind of advance on this are diagnostic features. So in the future, we would be able to configure it to have your cable inspection scope or interface built into the software. So you wouldn't have to change between multiple applications to check an interface for a cable before testing a cable, things of this nature. Or things like, would you like a note kind of system, or to be able to import kind of a work instruction or a workflow built into the software so your users can always kind of follow what they need to do, things like this. So these, again, are plugins that only change the user interface. They don't affect the engine, which is measurement and exporting data. So that's everything I wanted to cover today. So thank you, OIDA, for putting this on. And thank you, Sakshi, for putting it together. Again, my name's Thomas, and we'll have a live demo set up in our networking room. We'll be in there for the next couple hours. So if you have any questions or would like to see the software in use, please stop by. Thank you.